Alright, for today's problem, I will talk about party lamps. In this problem, it may seem complicated because this counter value, which is C, can be at most 10,000. But if you think about it, for every button, if you press them twice, it basically means that you didn't press them at all. Because if you switch them on and then off, it will just stay off. And if you switch them on and then if you switch them off and then on, then they will just stay on. So for every even number of press, you will have it's basically same as not pressing the button at all. And if you press it an odd amount of times, then it will mean that you pressed it once. This will be the same for each of the 4 buttons, and there are only 4 buttons, so then they will be pretty easy to compute. So here's my code. It may seem confusing, but it's actually not very hard. So here, after reading all the inputs, I checked if C was greater than 4. Because we know that if it's greater than 4, then definitely there will be some repeated pressing, and then we can just minimize it to 4 presses, so then we don't have to recursion for too long. So here it checks if it's an odd number or an even number. If this is an odd number, then we will set this C to 3 no matter how big it was, because 3 will be the same. If you write out all the possibilities, you'll see that no matter how big it is, if it's greater than 4 and it's an odd number, then it will just have the same result as pressing 3 buttons. And otherwise, if it's an even number, then it will basically have the same result as pressing 4 buttons. So first you create this bit set, which is basically the same thing as a Boolean array. You can also use that if you want to. And you use this to set all of it to true, because we know that in the beginning all of the lamps are turned on. And then we use this search method, which is a recursion. And here's the search method. And here we'll receive 3 values. One is our bit set, which is our current state of the lamps. The second one is K, which counts how many times we've already pressed the button. And then the third one is this previous one, to check which button did we press in the previous round. So first it checks for this basic thing if K is already equal to C, which means that we've already pressed it C times. Then we will need to check if this current state is an acceptable state. If it is acceptable, then we will push this back into our answer vector. So this is the check function. After it receives the state of the lamps, it will check if each of them are turned on or off. If one of them is turned on and we already received that it's supposed to be off, then we know that this definitely can't be the right combination, so we'll return false. And it's the same thing vice versa. If this is off, but we know that it's supposed to be on, then we also return false. If we loop through all of them and none of the cases are like that, then we return true. So if it's true, it adds that and returns this, stops this current recursion. Otherwise, it will test for each of these button cases. So first of all, this is the first type. You can press button 1 and then it will flip all of the lamps. So the ones that are on will turn off and ones that are off will turn on. So this is what this flip does. And then this is what the previous integer does. If we know that our previous one was 1, then we can search this. But if it's greater than 1, then we shouldn't search this, because, for example, if you press button 2 and then press button 1, it will have the same result as pressing button 1 and then pressing button 2. So you don't really want that to happen, or because it's going to just take more time and it's also going to have repeating answers. So you just have to make sure that each of the previous ones are smaller than or equal to the button that you're currently pressing. So we add 1 to K because we pressed an extra button, and we note and our previous press button was still 1. this is the second case where it finds all the odd numbered lamps. And this is the third case where it finds all the even numbered lamps. So if it's not divisible by 2, this means that it's odd for each of the bits inside our bit set, which is basically each bit represents whether the lamp is turned on or off. So this means that it reverses the sign. This means not of the state. So if it's on, then it will turn off. If it's off, it will turn on. So this is our temporary array number 1, and this temporary bit set number 1, and this is the temporary bit set number 2. We use these two to keep track of one for button 2 and one for button 3. And then here's our button 4, which is the final button. You can basically start at 1 and increment 3 every time, because that's what I want us to do, 1, 4, 7, and so on. So you increment 3 as long as it's smaller than our total length. Then you set this temporary bit set number 3 into the reverse of it. And here's where we use recursion again. If our previous button pressed was less than or equal to 2, which means that we've pressed either a button 1 or button 2 in the previous round, we can press button 2 again, because same thing, if you already pressed button 3 or button 4, then you don't want to go back to pressing button 2 again. And then this is the same thing if you press buttons buttons that are less than 3 or equal to 3, you can press button 3 again, which is our the arrays that we have, which is the bit sets that we've already found. And otherwise, we know that it would definitely be less than or equal to 4, so you don't really need to add an extra if, but you can add it there for more logical sense. So if otherwise, then we will search the final, or we will search what will happen after we press the final button, and then it will just keep on incrementing k until it reaches something and it returns. So after that, we will have already pushed all the answers into the list. We just need to sort this answer, and I think there's no comparison available for the bit set. So then you have to create a compare function by yourself, and so this compare function will receive 2 bit sets. This is how we will sort our answer vector, which is filled with bit set. So here in our comparing function, we will loop through each of the bits in our bit sets from 1 to n, and as long as it's not equal to each other, if it's not equal to each other, we will return whether the bit in bit set A is smaller than the bit in bit set B. And what this basically does is that it will just compare all the smaller ones, will return 1, and will be sorted to the front, because we want the order from, we want it to go from least to largest. So this is what it does. And otherwise, you can just, if it's all the same, then you can just return 0 or 1. It doesn't really change the answer. So we will loop through all of our answers and print them out. But using this recursion method, we'll still sometimes have repeating answers. So you have to compare this first to see if we have repeating answers, which means that if the current answer that we're looking at is the same as the previous one, we can just skip this one because we've already printed the previous one. So after, if it's a new one, then we will get this into I. You don't need to do this, you can just print it out if you want, but just to show you. So then we will print, we don't want to print out all of the 101 bits, we just want to print it out to the length that we want. I did 101 because this bit set have to be set in the beginning, and our maximum is 100. So here, after I will go through from 1 to n and print out all the bits in this range and print a new line. Otherwise, if we don't have anything, if the answer vector is empty, we'll print out impossible and stop this program.